Welcome, friends. This is the module 1 of our business statistics course. So, if you can recall in the last video, that means the introduction video, we just introduced the subject to you and defined the modules and the course content. And after that, in the last two slides, we have introduced the concept of statistics and how a statistician is supposed to ask any question or answer some of the questions using statistician's language. And after that, we just have seen the flow chart where the first part was, of course, sampling, and then it was descriptive statistics. So we are starting off with descriptive statistics. So my idea is I have divided module 1 into two parts. Part 1, that means today's lecture or today's video, that is the part 1 of this, uh, where we will just introduce certain terminologies related to descriptive statistics. And in the next part, that means in the next video, we will calculate all those statistics and parameters using a particular data set. So in today's video, we are just introducing the topic of descriptive statistics. So if you can define descriptive statistics most simply, it is the collection, summarizing, classification and presentation of the data. So in case of descriptive statistics, data is collected from a particular sample, it is summarized, then classified in different various possible ways, and then presented in a particular format. So our job in descriptive statistics is not to infer anything. So when we are in descriptive statistics, we are never using the reports or the charts or any other format data in order to infer anything. So the main purpose is to get a feel of the data, what the data is telling you. So only that portion, and collecting the sample statistics, not to infer anything from the descriptive statistics module. So that's it. Let us then go to some definitions. First one is the most important, population. What is a population? Population is the complete group of interest for a certain study. So if you want to carry out some statistical study for a particular group, the entire group becomes the population. And as you may know that population is most of the time impossible to study. Why? Because there can be various reasons. One is simply the time and cost. The time and cost for studying an entire population may not be justified. And what is more important is, even if you allow time and cost, it may not be possible to access the entire population. So in most of the cases, we will not have any access to the entire population. So it is not possible to study it. So then what is possible is collecting a sample. What is a sample? Sample is a selected group or subset that is taken out of the population using various methods called the sampling methods, which we will see in the last module. So for conducting the study, we are taking a particular subset using some methods that is called sample. And then what is a parameter? Parameter is a measure for the entire population. So when we are talking about population, any measure related to the population is a parameter. So examples include mean, standard deviation, variance, correlation coefficient, and so on. So here, if you are uh, concerned about the mean in case of population, then it is the population mean. This is the population standard deviation, population variance, population correlation coefficient, and there may be others also. These are only the examples. And then what is a statistic? Statistic is always associated to a parameter. So if there is a parameter, then there is a statistic also. So for example, you use Greek letters mu, sigma, sigma square, maybe this is row. These are for population parameters. Then correspondingly, we will have a sample mean. Sample mean, we write it as x bar. Then sample standard deviation, we write it as small s. Then sample variance. Sample variance, small s whole square. Then sample correlation coefficient, often written as small r. So whenever you encounter this type of variables, even if it is not defined anywhere, you should always understand that it is sample statistics. For example, someone is telling you in the standard deviation is equal to s equal to 10. It is implied that when it is s, it is a sample standard deviation. Otherwise, if sigma is written, it is implied that it is population standard deviation. That's it. Okay, so in the next slide, this is very important, classification of data. So how many types of data are possible? But before that also, what is the basis of classification? That means what are the criteria? There are four criteria as you can see here. So first one is, can the data be measured? What does that mean? Means you have a data, can you measure it using either using manual process manually or using instruments? Can you measure the data? That is number one criteria. Can it be ordered? What is ordering? For example, if I order some kind of data, will it have any meaning? Let us consider this example. Suppose disease, some kind of disease is there, and there are various levels. For example, liver problem. You may have heard liver problem may have level 1, 2, 3, or 4. So level 1 is mild problem. This is mild. This may be little serious. This is severe, and this is morbid. Okay. So what I'm trying to say here is these levels are ordered. You cannot change the order. Serious cannot come before mild. Morbid cannot come before severe. So in this way, 1, 2, 3, 4, this order is valid and cannot be changed. And therefore, this type of data is ordered data. So this is known as ordering. Then the third point is, third method of classification is whether or not the data is equidistant. What is equidistant? For example, you are measuring temperature. Okay, you are measuring temperature, then the ratio between 10 degree and 20 degree, what is that? 0.5, right? Then between 20 degree and 40 degree, that is also 0.5. The ratio is always equal. That means what? If you plot 10 degree, 20 degree, 40 degree, then 80 degree, always it will have a same ratio, and this ratio cannot be changed. And also this ratio will have some meaning. So if you take the ratio of 10 degree and 20 degree, it is coming equal to 0.5, and that 0.5 has a meaning. So you cannot, for example, this level 1, this is level 1 and level 2. You cannot say that level 1 divided by level 2, that is equal to half or 0.5. Okay, you can divide 1 by 2, but this 0.5 has no meaning in itself. So this is not equidistant. And the last one is, there should be a meaningful zero. Meaningful zero means, suppose again, if you take the example of temperature and you plot the temperature, you will suppose in a particular graph, this is, suppose this is time and this is temperature. So always you will have a meaningful zero. So 0 degree centigrade or 0 degree Fahrenheit. it is a meaningful thing. Okay, so that is the meaning of meaningful zero exist or not. So based on that, I am deleting some of these. Okay, so based on that, we will define four types of data: categorical, ordinal, interval, and ratio. So, for example, for categorical data, it cannot be measured, it cannot be ordered, it is not equidistant, and it does not have any meaningful zero. So, some examples are gender, favorite color, nationality. So, in this type of situation, the output of the data will be categories. For example, in case of gender, male and female categories. See, no measurement is possible. Ordering is also not possible. Male greater than female or female greater than male, meaningless. Equidistant is also meaningless. Meaningful zero is also not possible. So these are the categorical data. Then ordinal data is almost the same as categorical data. Only difference is it can be ordered. So it cannot be measured, it is not equidistant, it does not have any meaningful zero. Only difference is it can be ordered, like stages of disease, as we have discussed already here. Then steps of exercise. This type of data often it will look like interval or ratio data. For example, if you take level, then 1 2 3 4 may be there. It looks like they are numbers, but they are actually not numbers, they are categories. And they are ordinal because the order is valid. 1 2 3 4 order is valid. If the order is not valid, then also it is categorical. For example, say while entering a particular data, in case of gender, one is male and two is female. So see, here you cannot say that one is greater than two or two is greater than one. This is meaningless. This is meaningless. We just given numbers here just to identify some categories. These numbers are actually not numbers, they are also categories. So please be very careful. Just by looking at the numbers, you cannot say it is categorical or ordinal or interval or ratio. You have to check actually these 4 points in order to classify the data. So therefore, the next data is the interval data, where measurement is possible, ordering is possible, equidistant, but there is no meaningful zero. For example, date or time. Okay. Then what is ratio? Ratio is the most superior data compared to all these four, where it can be measured, can be ordered, equidistance also, and it has a meaningful zero. All kind of measurement variables like age, temperature, length, all these things are ratio variables. So please remember the chart. This is very important. So if you are if you encounter any kind of data, so deciding may be sometimes challenging, may not be that straightforward always. So often you may need to think about these four classification criteria, and based on that classify the data. Okay. Then next topic is, if you have already collected the sample, what we will do with the sample. Then there are several aspects of the data, aspects that needs to be clarified here. The first aspect is the central tendency of the data. So now consider this simple example here. Suppose true weight of a particular substance is 80 kg, suppose. Okay, and then you take 5 samples or 5 readings, and you are getting this particular data: 100 kg, 70 kg, 100 kg again, 70 again, 60 again. So see, if you take the average of these 5 figures, the average figure is always equal to 80. You can check that: 100 plus 70 plus 100 plus 70 plus 60 divided by 5, you will get 80. So if your average is quite close to your target, that means here it is 80, here it is also 80. So it's about accuracy of the data. So when we are talking about central tendency, it is about the accuracy of the data. And how to define accuracy? Accuracy means, suppose this is target, this is your target, and you are either here or here or here or here or here or here, and average of these things is also the center. You may be here or here or here or here or here, still your average is here, then also you are accurate. Then you may be here or here, then here, 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 and here, still your average is here. So that is also accurate. So no matter how much distant you are from the mean, if all are equally distant, then or the average is centered toward this mean, then your data is accurate. So central tendency is about the accuracy of the data. Please remember this. And what are the measures for central tendency? The first one is the mean, then median and mode. Mean is basically the simple average, as we have discussed here. 100 plus 70 plus 100 plus 70 plus 60 divided by 5, that will be equal to 80 in this case. So this is the mean. For median, we need to order the data. So first of all, order this in a ascending format: 60, 70, 70, 100 and 100. Then we need to take the central value. Once the ordering is done, the central value is the median. Then what is the mode? Mode is the frequency. Based on the frequency, we are selecting the highest frequency observation. So for example, 100 is here twice, 70 is here twice, and 60 is here just one time. So total is 5. So you can see the most frequent observation is 100 and 70 both. So we will have mode is equal to 100 also and 70 also. So this is a bimodal data. Okay. Now the dispersion. So unlike the central tendency, dispersion is about precision. So what is precision? So you can check here, although the average, as we have discussed in the earlier slide, the average is 80, no doubt, but you see the dispersion here, the distance from 80, 20 units of distance. Here it is 10 units of distance. Such a huge variation. And if you cannot understand this, you can take this example also. So suppose this is 80, the true value or the target value is 80. Then the first observation is suppose 400. Okay. And all other is 0. So then what is the average? Average is still 80, right? Total is 400 and divided by 5, which is 80. So it is accurate. Again, it is accurate. But can you see the dispersion? It is not at all precise. So again, mostly there are three measures of precision or dispersion. That is, first one is range, which is the maximum value minus minimum value. In this case, what is the maximum value? It is 100 minus the minimum value 60, that is 40. 40 is the range. Standard deviation can be calculated using these two expressions. So you need to subtract the mean from each individual observation, then square it, then add the squares and divide it by the population size and take the square root. This is the standard deviation of the population. While calculating the standard deviation for the sample, in the denominator, instead of having the sample number of samples, you need to take the number of samples minus 1 and then take the square root again to get the standard deviation. The standard deviation can be thought of like it is the square root of mean squared errors. Okay, so these are the mean squared errors, and this is the squared errors basically. And when you divide it by sample numbers, this become mean, and then you are taking the square root. And variance is simply either sigma square or a square. And then there is another one known as coefficient of variation. So sometimes it is possible that standard deviation or variance may not be appropriate measure for this person. Why? Because suppose you are comparing two sets of data, the nature of the data may be actually similar, but the absolute values are different. For example, uh, suppose you are comparing the stock prices of two stocks. One is suppose $50 of value, and another one is $400. So if you try to fit the same, uh, if you try to compare them, then standard deviation and variance will give you elevated values for this one and smaller values for this one, while the variability may be comparable. So in case of comparing these two stocks, you need to have a relative measure of dispersion, which is the coefficient of variation, where simply we will divide the standard deviation by the mean. So precisely these two measures are absolute in nature, and this is the relative measure of dispersion. Okay, then finally, after knowing the central tendency and the dispersion, we need to see the shape parameters. There are two aspects of shape. One is the skewness, and another one is the flatness. The skewness is as it is described here. See, if the data is skewed symmetrically around the mean, like perfect bell-shaped curve, then it is called the symmetrical distribution, for which the mean, median, and mode should coincide. And this type of distribution is often known as positive skew, where the right tail is longer than the left one, and therefore it is sometimes called right skewed also. And similarly, this is called left skewed. Okay, why? Simply because the left side is tail of the left side is longer than the right side. And please note this, when you are dealing with right skewed distribution, then the mode is always less than the median, and median is always less than the mean. This is actually exactly opposite for a left skewed distribution, where mode is greater than median and median is greater than mean. Okay, and this is the second aspect of shape parameter, that is the flatness or the peakedness. Three types of situations may arise. One is that it is too much peaked, and or it is too much flat, or just normal. So three definitions are given here. I mean, not definition, just name. So somebody is telling you, if it is leptokartic, know that the distribution is too much, like this type of peaks are there. And if it is platykartic, then that means the distribution is quite flat. And if it is mesokartic, that means it is quite like normal distribution, not too much flat, not too much um, peak. And now, just by looking at this, you may not figure out there are other parameters also, like shape parameters, shape parameters, both for skewness and for flatness, measured by particular statistics that we will learn when we will actually study the data set. So based on the values of those parameters or statistics, we can say whether the distribution is symmetrical or right skewed or left skewed, or in case of this, whether it is leptokartic, mesokartic, or platykartic. So that's all. I think you have understood the content, because I don't want to repeat this again in the next video. All these things will be calculated using Minitab or Excel using the data set. Before that, please go through these slides and try to understand every point. These are simple, not very complex things. Many of you may already know these things, but in order to explain certain things in the Excel sheet or in the Minitab, I need to create a particular foundation, and that was the purpose of this video. So please watch this and also the previous video, and make sure you understand all of these points. Thank you for watching this video. Let us meet in the next portion of the module in the next video. Thank you so much.